Today we're going to look at exponential growth and decay. As always, here are the state standards. Please refer to these as needed. Your success criteria, what you need to be successful today, you need to be able to determine whether data represents exponential growth or exponential decay. You need to be able to write an exponential growth function and exponential decay function. You need to be able to solve real-life problems using exponential growth and decay functions. All right, your vocabulary, exponential growth, occurs when a quantity increases by the same factor over equal intervals. An exponential growth function has the form y equals ab to the x power, where a is greater than 0 and b is greater than 1. You can write the growth factor b as the sum of 1 and the rate of growth as r. Exponential decay occurs when a quantity decreases by the same factor over equal intervals. Exponential decay function has the form y equals ab to the x again, where a is greater than 0, but this time b is between 0 and 1. You can write the decay factor as a difference of 1 and the rate of decay r. All right, so key ideas here, exponential growth functions. You can see y equals ab to the x. We got introduced to that in the previous section. Now we're going to look at it a little bit more in depth. All right, a is greater than 0, b is greater than 1. That means you're looking at growth, exponential growth. All right, you can write the growth factor b as the sum of 1 and the rate of growth as r. So, ab to the x power, rewritten just a little bit, y equals a. Instead of b, we're going to do 1 plus r raised to the x power. This 1 is very important. You know, if you multiply something by a percentage, then it's going to be only that percentage you're going to get. If you multiply it by 1 plus the percentage, that means that's what's going to show it growth. Anything times 1 is itself. So you want it to be anything times 1 plus that rate so that it represents your growth. All right, same thing about decay, except now your b is going to be between 0 and 1. So now you're going to do 1 minus your rate. All right, and we're going to look at some examples of this. All right, I know I went through this kind of quickly, but you can always rewind and watch again or reach out and ask questions, and please do so if you have questions. All right, let's look at some examples. Example 1. The inaugural attendance of an annual music festival is 150,000. The attendance y increases by 8% each year. Write an exponential growth function that represents the attendance after t years. About how many people will attend the festival in the 5th year? All right, so first thing is understanding the question. So it says inaugural attendance. That means the first year's attendance. So the music festival has 150,000 at the beginning. The attendance y increases by 8% each year. All right, so first think about our exponential growth factor, okay? Y equals a times 1 plus r raised to the x power. Sometimes we use t for time. In this case, since we are talking about t years, let's go ahead and change this to t. That'll still be our independent variable. All right, so what do we know? We know the first year, or our starting point is 150,000. So we know that's going to be our a value. So this right here, we know that's going to be a. We also know that it's going to increase by 8% each year. We also know that we can write 8% as a decimal. All right, so 8% or 0.08. So let's go ahead and plug in what we know. So we know that A is 150,000. And 1 plus our rate is 0.08. And that's going to be raised to the t number of years. All right, so if we want to write the equation for the attendance for the festival, we can say y equals 150,000, 1.08 to the t power. And then it says about how many people will attend the festival in the 5th year. So if we want to know how many people attend in the 5th year, all we have to do is substitute 5 in for t. Actually, we're going to start with t equals 0 as our first year because that's our initial value, our y-intercept. That's what creates a to be the y-intercept because anything to the 0 power equals 1. And then 1 times a would be a. So we got to start with t equals 0, and then t equals 1, 2, 3, 4. So actually 1, 2, 3, 4, 5. So to find out how many people attend the festival in the 5th year, we're going to substitute 4 in for t. So y equals 150,000, 1.08 to the 4th power. All right, let's see. All right, just trying to type in the equation, being careful to make sure everything gets typed in correctly. And that shows that there's going to be an estimated about 204,000 people will attend the festival in the 5th year. So you can just round this number. So you can just say about 204,000. So about 204,000 people will attend the festival in the 5th year. Attend the 5th year. One way you can double check this is you can go to your graphing calculator. You can type this in. I went ahead and typed this in, 150,000 times 1.08 raised to the t power. I just put x in here, but it's the same thing. So I've put in our function that we wrote. And if I hit graph, it's not going to show up right now because I don't have it up to 150,000. But I can look at my table of values. And if I come down here to where x is 4, you can see that it is about 204,000 people. So we can be assured that we did this correctly, and using a calculator to check yourself is a great thing to do. Example 2, we're going to determine whether each table represents an exponential growth function, an exponential decay function, or neither. And we need to explain as always. All right, so here we can divide 90 by 270, 30 by 90, 10 by 30, and that tells us that what our decay or our growth function is. So we can do, let's see, 90 divided by 270. Well, missed the division sign there. 90 divided by 270. Try one more time, 0.333. Okay, 30 divided by 90, that's a little bit easier to see. 30 divided by 90, you should know, is 1/3. And 10 divided by 30 is also 1/3. All right, and if you want to change this, if you don't know that 0.333, you can change this to a fraction, and it's going to tell you that that is all equal to 1/3. So here I am multiplying by 1/3. So that means this is a decay function. And it's a decay function because your b value is between 0 and 1. So this is 1/3, and this is 1/3 as well. All right, so as x increases by 1, y is multiplied by 1/3. So the table represents exponential decay. So I'm just going to write decay here. All right, so the next one, same thing, 10 divided by 2. 10 divided by 5 is 2. 20 divided by 10 is 2, and 40 divided by 20 is 2. Sometimes my brain and my mouth get confused, so sorry about that. Hopefully you are following along and you understand what I'm doing. So again, my x's are increasing by 1. This time my y's are increasing by multiples of 2. So as x increases by 1, y multiplied by 2, so the table represents exponential growth. All right, it says which one doesn't belong, which function does not belong with the other three. Explain your reasoning. Y equals 5 to the x power. Y equals 2 times 4 to the x power. Y equals 0.3 to the x power. Y equals 5 times 3 to the x power. So what do you notice? Y and f of x are just two different ways to write it. This is just function notation, but hopefully you know these are all the same. All right, so this one doesn't have an a, so we assume it to be 1, but your growth factor is 5. This one has a growth factor of 4. This one has a decay factor of 0.3, and this one has a growth factor of 3. So out of all of these, I would say the one that is different would be this one because it's a decay function instead of a growth function. Example 3, determine whether each function represents exponential growth or exponential decay. Identify the percent rate of change. All right, 5 times 1.07 to the t power. This is greater than 1, so this is a growth factor. Remember, it's 1 plus r, so r is 0.07, which is 7%. All right, f of t equals 0.2 times 0.98 to the t power. This is less than 1. So if it's less than 1, that means it's a decay. So this one's growth. This one's decay. And you know that by the b factor. This number right here is your b. That tells you whether it's growth or decay. Greater than 1, less than 1. All right, so how do you know what the decay factor is? You would do 1 minus 0.98, and that equals 0.02. So 0.02 is the same thing as 2%. So it is decaying by 2%.